Hey, what's up, AP Calculus students? This video is going to go over the 2.5 Part 2 notes. So we are going to be continuing on with some more examples of implicit differentiation. And yes, I rather have feet for hands than hands for feet. So in problem number 1, we're being asked to find the second derivative of this equation. And we're going to express our answer in terms of x and y. So we're going to have to figure out the first derivative before we can get to the second derivative. So let's just take that equation over here. We'll leave it in this form and just do implicit differentiation. So that would give me 2x minus 2y times dy over dx equals 0. We're going to isolate the dy over dx by subtracting 2x and dividing by negative 2y. So that means my first derivative is equal to positive x over y. So this would be my first derivative in terms of x and y. And now we're going to take the derivative of this equation to get to our second derivative. So let's just draw an arrow over here. So the dy over dx becomes d2y over dx2 when we take its derivative. And on the right side, we're going to have to use the quotient rule and also be mindful of the implicit differentiation. So that would be low multiplied by d high minus high multiplied by d low. So the denominator says y, y's derivative is 1, but that gets multiplied by dy over dx using our implicit differentiation. Now the denominator is just low, so let's call that y squared. So at this point, we have our second derivative. It's just not in terms of x and y because of this dy over dx part. So what we're going to do with that is we're just going to replace it with what it's equal in value to, which is actually x over y. So taking this a step further, y times 1 is y, minus x multiplied by the dy over dx, which is just x over y. And then that goes on top of a y squared. Now, I can multiply the x to the numerator because this is like x over 1. So that'll give me y minus x squared over y divided by y squared. We are in terms of x and y, but this is a complex fraction. Complex fractions are not considered to be simplified all the way. So I want to eliminate this extra denominator. So to do that, I could just multiply everything up here by y, but that means I'm going to have to multiply everything in the denominator by y as well. So distributing that y to the parentheses would make my new numerator y squared minus x squared. In the denominator, now I have y cubed. So my final answer is in terms of x and y. It is simplified so that there's no complex fraction. But I'm just going to do an or here. Sometimes in the multiple choice part on the AP test, if there's a way to write this even more simplistically, is that a word? Sure. They're going to do that and make that the answer choice. So what I mean by that is if you go back up here to x squared minus y squared equals 9, if I move this stuff around so that the equation says negative 9 equals y squared minus x squared. Now I know that when I see y squared minus x squared down here, it is equal in value to negative 9. So they might have the answer choice written as negative 9 over y cubed, and that would be the one you want to pick. But if this were a regular question on one of my test or quizzes, I'd take either form of the answer. You just can't leave the dy over dx in your final answer. Okay, moving on to problem number 2. This is a multiple choice question. I put the graph there. The graph isn't actually supposed to be there, so this is the type of question you should be able to come up with an answer to without seeing the graph. But since the graph is there, I'm just going to go to the point 1, comma 2, and my eyeballs are making me think that there would be a horizontal tangent line there. So I'm just basing this off of looks. But like I said, this graph would not be there on an AP test, so you'd have to actually know how to do the math to come up with your answer. But since that looks like a horizontal tangent line at that point, I'm thinking that the first derivative exists there and the tangent line is horizontal. So I'm thinking the answer to this question is B. but we're going to put the math in just to make sure. So let's grab our equation. Let's write it down here. I'm going to put some parentheses around that x times y. And why don't you guys pause the video, see if you could get the first derivative using implicit differentiation. Just watch out here, you're going to have to use the product rule. All right, welcome back everybody. Hopefully you're able to come up with this answer. So like I said, I did do the product rule in the parentheses. This is here because of the implicit differentiation. And that is there because of implicit differentiation. So what did I do next? I distributed the minus sign to both things in the parentheses, giving me minus y minus x times dy over dx. I added the y over to the right side, subtracted the 2x over, factored out a dy over dx from these two terms. I just put the 2y first just because I like the positive term first in line. And lastly, I just divided each side by 2y minus x. So now that we have our equation for the first derivative, we can evaluate it at the point 1 comma 2. So you could just write that notation this way. And every place we see an x, we'll put a 1. Every place we see a y, we put a 2. All right, so that would give me 2 minus 2 times 1 over 2 times 2 minus 1. So my numerator is 0. My denominator is 3. 0 divided by 3 is 0. So the slope of my tangent line at 1 comma 2 is 0. So that means the derivative exists there, and there's going to be a horizontal tangent line at that point. So let's go with choice B. Okay, for problem number 3 on the back, this is actually a sample problem from an old AP test that involves implicit differentiation. So in the video, I'm just going to go over part A and B. We could talk about part C and D in class next time I see you. So what they're giving you guys is this equation, and they tell you that y is greater than 0 for that equation. And they want you to show that the first derivative comes out to this. So oftentimes in an open-ended question, they will tell you what the first derivative comes out to. You just have to show the work. That way, when you go to part D, for example, and you have to get the second derivative, you know that your first derivative is correct. So let's go over part A. And what we're going to do is just take that equation, and I want you to pause the video and see if you could get the first derivative to come out to what they have there. Okay, welcome back everybody. So let's see, the left side would be 4y dy dx, 6's derivative is 0. On the right side, I'm doing the product rule. So second times derivative first plus first times derivative second. I subtracted this dy over dx term to the left side, so it's by its buddy. And then I factored out the dy over dx, did a division, and I ended up with the first derivative that they wanted me to end up with. Okay, part B wants us to get the equation for the tangent line at the curve to this curve at the point 0 comma net radical 3. So we have our x and y. We just need the slope at that point. And since we know our first derivative, what you're going to do is just evaluate the first derivative at that point. And then that'll tell you the slope of the tangent line, and then you can write the equation of the tangent line. So why don't you pause the video, see if you can do that. We'll check it out in a second. All right, welcome back everybody. So substituting 0 for x and radical 3 for y into the first derivative would give you a slope of 1/4. Here I'm setting it up with the point slope formula, and then I just change it to mx plus b form. So this form or this form would be correct. And like I said, we'll do part C and part D together when I see you next time. That's worth discussing live so that you get to have a little better understanding of it. Okay, guys, I will talk to you next time. Toodles.